I'm sorry, we did not get your name. After you state your name, please press the pound key. I'm sorry, we did not get your name. After you state your name, please press the pound key. You are the first participant in this conference.
Yeah. Hello? Let's try again.
It did. It's supposed to say it will not be placed in the conference.
That's right.
Or actually, it'll say, as a moderator or whatever, it says, if you want to mute, press star, whatever. Then it says, but it's not starting the conference. Weird.
Hello?
Okay. Let me call them. Haven't forbid anything.
You want to call them on my cell?
Haven't forbid anything.
Mm-hmm.
So they're getting nothing.
Oh, you've got Bruno on here, do you? I can't recognize a lot of these. Oh, so for Scala?
Okay, it's not working.
on?
Oh, yeah, sure.
What could possibly be wrong?
Unless the phone number isn't, but it's a number because it's being allowed to dial in.
Yep.
It's not telling you that you've got the wrong number or the wrong access code. It's just not connecting to a joint call line. That's ridiculous.
Could it be that this is not the right one for this?
Well, then if it was. Supposedly we're on.
Can people hear us out there?
Yep.
Excellent. We'll be starting in a few minutes.
My stuff if you want.
Oh.
The conference is in lecture mode.
We got 2 minutes. Star 6 is mute.
Well, shouldn't you be able to use the mute button on my mute?
Hello, folks. We are just waiting for a few more people to log in here. We're expecting about 70 people. So as soon as I see that number get close to 70, we'll get started here. Okay, ladies and gentlemen, it's Gary Sharp here from the Canadian Home Builders Association in Ottawa. We're starting a couple of minutes late, but I see there are still some people joining the webinar, but I think we'll get underway. This is the second webinar that we're hosting in our series relating to the code changes to the National Building Code. And this one is on 6-story wood frame buildings. Before we get started, I've got a couple of housekeeping items that I want to go over. First of all, we are putting the webinar on lecture mode, which means that you can hear us, but we can't hear you. So if you have any questions that you would like to ask, please use the chat feature, and you can direct those questions to either myself, Gary Sharp, or to CHBA, or you can direct those questions to all. As a courtesy to our presenter, I'm going to hold all of the questions to the end, and then we'll read each one so that everyone knows the question, and we'll ask our presenter to respond. The webinar is being broadcast so that you can hear it on your speakers on your computer. So if you want to free up a telephone line at your office, you don't actually need to use the telephone line. You should be able to hear this webinar right through your computer speakers. We have with us here today Ineke Van Zeelen, who is the Manager of Codes and Standards with the Canadian Wood Council. And at this stage, I'll pass the microphone to Ineke, and we'll get this show on the road. Thanks very much, and over to Ineke.
Thank you, Gary. I'm actually quite surprised at seeing how many people are online, but pleased. I mean, it's been something that I've been working on for a little while, and I'm glad that so many people are interested. So, as Gary mentioned, I'm going to talk about the 5- and 6-story mid-rise code change proposals for wood buildings, or actually combustible buildings, really, in the National Building Code. And then I'm going to talk a little bit about some of the research that we've been doing. There we go. But first, some of you may not be aware, I know a couple of you on the line are quite familiar with the Canadian Wood Council, but just for those of you who aren't really familiar with us, we're actually a national industry association. We're the technical industry association for the wood industry in Canada. And we are actually a national federation of associations, which means that various associations are members of CWC, and their members are the manufacturers of wood products. And so you can see the variety of associations that are our members, and that means that we represent over 1,000 manufacturers of various wood products across the country. The majority of them are solid sawn lumber, but there's also some panel products like plywood. We represent glulam, treated wood products, and some engineered wood products such as wood trusses. So as I mentioned, we're going to talk a bit about the proposed changes for the height and area requirements for combustible buildings in the code, what we've been labeling 5- and 6-story mid-rise. I'm going to talk a little bit about the research project that's been ongoing for the last 2.5 years that is going to terminate March 31st, 2014. Unfortunately, we're a little behind in our report writing, and so I can't actually provide results yet, but what I can do is give an idea of the kind of information we have developed that will be coming out. And so a lot of it is information that will be useful for designing and building these types of structures in a generic sense, as well as some additional work that will help feed into more work at the Code Center in terms of possibly taller and larger wood buildings than even these mid-rise proposals. And because we've got a good amount of time today, I'm going to talk a little bit about, if you're interested, some of the other code change proposals that are not directly related to mid-rise, but that actually will help feed into combustible construction. It's information that will make it easier to design combustible construction, and that includes mid-rise. So, as some of you are aware, our code is now an objective-based code, but all the acceptable solutions are still found in Division B of our code nationally. And so it's Division B subsection 322 that talks about how to construct a building in terms of heights and areas based on construction type and occupancy type. And really, our code has come to the point in 2010 where we really only consider in Canada two types of construction, and that's combustible construction and non-combustible construction. And that's different from a lot of other jurisdictions. Even the United States has multiple types of construction that allow different heights and areas for those different types. In our system, even heavy timber construction has really become just a very small subset, specialty subset of combustible construction, and there's not a lot of different provisions in terms of heights and areas when you're using heavy timber construction. So this is just an example, a summary of an example of how our code deals with heights and areas in terms of number of stories and the maximum building area, which is basically the footprint of a building. You know, there's a very specific definition of how to calculate the building area. But of course, also within the context of an occupancy type and the number of stories, the maximum allowable building area changes dependent on whether you've got a sprinklered or unsprinkled building, and whether or not when you've got an unsprinkled building, whether it faces 1, 2, or 3 streets, and that's for firefighter access. And of course, the greater the number of streets you face, the greater the building area permitted. So that's how our code currently works, and this is just one example of the residential type Group C. There's also an example here for business type, and the reason why I mention these two in this part is because these are two of the areas that the mid-rise code change proposals particularly targeted. Now, not all of you are familiar with the national code process, so I'm just going to give you a little bit of an idea of how it works in general to understand how the code change proposals were developed for mid-rise. The CCBFC, or the Canadian Commission on Building and Fire Codes, is a volunteer stakeholder organization that works with the Code Center at NRC as the secretariat that basically provides the overall policy and guidance to the national codes in Canada. And they do that in consultation and partnership with PITAPAC, which is the Provincial Territorial Policy Advisory Committee on Codes. That one always gets me. And they, of course, the provinces are directly linked because they're the ones that are required under the law to implement building codes, to adopt them and implement them. And so they have their own ideas of the things in their provinces that are important to them, what areas they believe need to be looked at. And the idea is that at the national level, we would try and coordinate the priorities based on the provincial priorities. And so they have provided quite, in the recent years, as the structure was developed, they provided a lot more guidance. Under the CCBFC are the standing committees, and the standing committees are the technical bodies, again made up of volunteers from all segments of the construction industry, that provide technical recommendations to the CCBFC on code changes that are necessary or desired. For example, the Standing Committee on Fire Protection or the Standing Committee on Houses and Small Buildings. So they're usually divided up by a topic area or part of the code, so that you end up with a group of people that are knowledgeable within a specific sort of topic or area. Those standing committees can create task groups or working groups to work on a variety of issues that are brought forward. And so that's sort of the whole overall structure. The task groups recommend code change proposals that go to the standing committees. The standing committees review them. They propose them to the CCBFC, and the CCBFC then will approve policy-wise whether they will go forward first for public consultation, and then in the final analysis, the ones that go forward for code changes for the next edition of the code. When it came to combustible construction, in 2009, some of you are aware, British Columbia put forward a change to their code related to 5- and 6-story combustible construction for residential only. And partly due to that and due to interest in that code change proposal in other provinces, and because the Canadian Wood Council also was interested in seeing mid-rise combustible construction, it was decided that a joint task group should be created, that this should be something done in the 2015 code cycle should be looked at the whole thing of whether or not why our codes deal with combustible and non-combustible construction the way they do. So the joint task group was formed based on that policy decision that this was something that should be looked at. It was decided, there are often joint task groups when there are topics that might that affect or deal with more than one topic or part of the code. And in this case, it was decided that the joint task group should actually report to 5 different standing committees. And actually, I'm pretty sure that almost all the other standing committees as well have looked at these code change proposals. Even the Part 9 Standing Committee on Houses and Small Buildings has at least reviewed the code change proposals in their meetings, just to keep an overall view of the whole process. So the joint task group was formed, and it was set up to, it was made up of stakeholders like any other task group. The Code Center has there's a policy within that system to make sure that you have full representation for all the interested stakeholders, as well as regional representation. And so there were regulators, industry reps, general interest groups, fire services, different provincial and municipal regulatory bodies, as well as the construction material interest groups. And at the very first joint task group meeting, a list of 65 concerns were put on the table by all the stakeholders that attended that meeting. And those 65 concerns created the basis for the process going forward in conjunction with the British Columbia's code change proposal, mid-res proposal, as well as one that the Canadian Wood Council put forward. Now, those 65 concerns were divided up by category and then assigned. It was realized that this was going to be a large task. And so the joint task group also set up 4 sub-task groups based on different topics to try and bring specific subgroups of experts together to discuss those particular issues. And so then the sub-task groups were formed. Those sub-task groups looked at the code change proposals, discussed all the issues that were assigned to them, and they generated recommendations on code change proposals that then went to the joint task group. The joint task group then reviewed those proposals, made some changes, asked for some additional information, asked the sub-task groups to go back and do a little bit more work on some items, and that went back and forth. And then the joint task group provided those recommendations, the finalized recommendations, to the standing committee. They also had some additional information they wanted, a bit of other, just to ensure that everything was covered. So that went, the whole process took about 2.5 to 3 years, I believe. And so that's where we came to today. The standing committees provided a finalized version, or recommended a finalized version go to public consultation this fall, and the CCBFC agreed that the package could go out this fall. So, as you are probably aware, there is the public consultation ongoing right now, and as I didn't realize until just a week ago, a little over a week ago, the actual closing date for that public consultation has moved from the original date of December 13th to December 23rd, which is good for me because I haven't reviewed all the code change proposals outside this package yet, and I need that time. But of course, as I just alluded to, this public consultation is much more than just the 5 and 6 story, and of course, you guys have been talking about some of the other areas. And there are a lot of very interesting code change proposals in this package, in part because this is the last major public consultation for the 2015 code. So it's a jam-packed session, really. So when it comes to the actual code changes for mid-rise, as I said, one of the basis for the original discussions was what British Columbia did. And on this slide, you've got the first 1, 2, 3, and 4 stories for Group C residential on the left-hand side shows what's currently in the National Building Code, and then the thing encircled in red is what British Columbia did in 2009, and then as sort of an interim change, and then formalized in their 2012 code last year. And so what they did was take a methodology that has been pretty consistent in a lot of the sections of our code for high scenarios, where we've sort of occasionally referred to it as the wedding cake approach, although that's not really a fully appropriate analogy. But the idea is that you take a certain floor area for 1 story as your building area, and if you take that floor area and divide it by the number of stories to create the building area for that number of stories, you end up with a building with a similar level of risk or hazard, as long as all the other things like construction, like your fire resistance ratings and other requirements are all the same. And so what happens is, for residential right now, you have, for a fire resistance rating of 1 hour, 1 story you're permitted combustible construction 6,200 square meters, and then you divide that by 2 for 2 stories, 3 for 3 stories, 4 for 4 stories, up to 1,800 meters. British Columbia said, well, if we follow that concept, we are quite confident that we are providing the same relative level of safety, so they just decided to take that base 7,200 and divide it by 5 and 6. And that's how they got 14,440 and 1,200 for their 5 and 6 stories. The Canadian Wood Council, when we put our code change proposal on the table, actually proposed slightly larger areas with additional measures in place to compensate for a larger footprint. Having been one of the people that wrote that proposal, I know my original idea was that the way that BC went was to just take the current article for 1 to 4 story and add 2 more stories to it. And our thought was, well, that sounds like a great idea, but we'd also like to see a larger base footprint. And so we thought perhaps the two proposals would go forward together. You'd end up with the same type of construction requirements, fire resistance and others, with the 1 to 6 under BC, and then a larger area with additional requirements. The Joint Task Group decided that only one path would be an easier approach, and so it was decided to take somewhere in the middle. The sizes are slightly smaller than what CWC originally proposed, I believe, but but there are additional provisions. So what's proposed for 2015 is 1 to 6 story combustible construction, a slightly larger initial footprint, so the building area for each of the number of story heights is slightly larger, but again it follows the same progression where you take the full area of floor area at 1 story and it's the same floor area for 2 stories, 3 stories, and you divide by the number of stories to get the building area. And what this resulted in is 1 story, 900 square meters for residential, and for 6 stories, 1,500 square meters instead of the 1,200 that BC currently has. And just for comparison, on the far right at the bottom is what non-combustible construction of similar performance in terms of fire resistance ratings and sprinklering and that is currently permitted, just for comparison. So you can see that we're still nowhere near what's permitted for non-combustible construction in this particular case. But, you know, small steps, and we're all happy that we've managed to get this far. One of the other things was that British Columbia had only, because they wanted to do a relatively quick change in 2009, they only looked at Group C, and the Joint Task Group agreed that, you know, in part this would be useful for things like main streets and that sort of thing, where people wanted more density, but also wanted to have small coffee shops, and mercantile on the main floor, or maybe the first 2 floors, and things like office space. So, because you're in a more urban area in a lot of cases with this type of style. So, it was proposed that Group D would be permitted to go to a full 6 stories. And again, looking at what the heights and areas are for the National Building Code, or what BC still has, I did this presentation last week in BC, which is why I show the BC code reference for this one too. Again, the proposals going forward provide for a larger building area at each number of stories, starting at 1,800 square meters for 1 story instead of 14,400, ending up at 6 stories at 3,000 meters instead of what would have happened with 6 stories if you just took the original areas. And again, as I said, we're nowhere near what the non-combustible construction is currently permitted. As well as being permitted the Group C and Group D, which would mean that any building that contains both of them could be 6 stories of combustible construction with the same requirements in terms of other performance aspects. one of the other things that our code does is if you do not have the type, the group or division type of occupancy that, if it's not permitted to go to a full 6 stories, if you have a major occupancy of that type in your building, then you end up having to either make separate buildings or you have to conform the whole building to as if the whole building was at height, meets the requirements of the code. So, but the Joint Task Group discussed mixed uses in terms of mercantile in particular. The Wood Council had proposed a 6-story mercantile, but it was decided that that was a little too much at this point, and so instead of that, they've gone this route. When it comes to mixed uses, Group A Divisions 1 and 3, Group B and Group F Divisions 1 and 2 will not be permitted at all in a Group C building of this type. But on the first and second story, Group A Divisions 2, Group B, and Group F Division 3, which is where storage garages, parking garages fit, will be permitted, and actually the Group F Division 3 would also be permitted on the third story. Now, the proposals also include some increased fire resistance ratings for separation between those major occupancies. And there's additional proposals that not only are you permitted these occupancy types as major occupancies within the permitted stories, but you can use the same construction type, combustible construction, 1 hour, except for the requirements for separation between occupancy types, for those parts of the buildings, even though there is no 6-story Group A2, there's no 6-story Group E. And so there's going to be a specific permission. And one of the things that we've had to do is, it was sort of very long to say, for the 5- and 6-story buildings of combustible construction of Group C and Group D, the new 322 articles are numbered 50 and 57, and all the other articles will be renumbered, so we were calling these the 50 and 57 buildings. So I'm going to use that terminology, which means the Group C and Group D buildings. So they're the 50 and 57 buildings. So if you build to the construction requirements of the 50 and 57 buildings, you're permitted these major occupancies within them. The same thing with Group D, even a little bit more, there's less restrictions on what's permitted. Group A Divisions 1 and 3, Group B, and Group F Division 1. And in Group D, on the first and second story, you're allowed Group A2s, Group F, E, and Group F Division 2s and 3s. And again, the F3s on the third story. Again, with with some increased fire resistance rating requirements for separations between those major occupancies. In addition to that, a bit like what British Columbia did, there's actually a new provision that's, there's almost no place in our building code except in defining what is considered a high building and when high building requirements kick in, that actually has a physical height restriction. But these buildings, these 50 and 57 buildings, the proposal is to have a physical height restriction based on the distance between the floor of the first story and the floor of the uppermost floor level. And that wording is important because, as some of you are aware, our code has some provisions that allow mezzanines to not be considered stories. And so the discussion was to ensure that a 6-story building, a building that was called a 6-story building by the definitions of our code, was physically a 6-story building in terms of sticking to an 18-meter height limit. And so, as opposed to being the floor on the top story, it's the uppermost floor level. So even if that's a mezzanine that doesn't count as a story, then that is the distance that you're measuring. One of the other additional requirements is that even though these buildings are sprinklered, there is a requirement for a 1-hour fire resistance rating for the roof, unlike any other building. And there's also some additional requirements related to the roof. If the roof, the highest point of the roof is 25 meters or lower, then you can use combustible construction for your roof, and you can use Class A, B, or C roof coverings. That's fine. You would be like any other combustible construction building. If the highest point of your roof is higher than the 25 meters, then the whole roof assembly system has to be non-combustible or fire retardant treated wood system, and the roof covering has to be Class A. Now, the one thing that was brought up was, well, what happens if you have varying heights on your roof? Well, the language is such that if that varying height of roof can be considered a single contiguous roof, so if parts of the systems join up in terms of like the surface of the roofing, or the sheathing, or there's a contiguous roof space, then those two roofs have to be taken together. So if the upper portion is above 25 meters and the lower portion is not, then you would still have to meet the upper portion requirements of non-combustible construction or fire retardant wood roof construction and a Class A roof covering. However, if those two sections were considered not contiguous, then each of them can be measured on their own. And so if you had a lower section that was completely separate than that portion, and that portion was below 25 meters, it would be permitted to be combustible construction and Class A, B, or C, and then only the upper roof would need to meet the more stringent requirements. Of course, these are the majority of the extension is 5- and 6-story buildings, and of course, for business occupancies, you need NFPA 13 anyway, so these buildings typically will have NFPA 13. For those buildings that are 4 stories or less, because we have provided larger areas for those 1- to 4-story buildings, those too will have to meet NFPA 13 as opposed to, no, those will meet NFPA 13R because they are 4 stories or less, which NFPA 13R permits. A bit different from what British Columbia did on the exterior walls, it was decided that the proposal would go forward saying that only when you have a building that's 5 or 6 stories under these provisions, and only on the 5th and 6th stories will the cladding need to be non-combustible or cladding that meets the requirements of a test, exterior wall assembly test, Canual CS 134. British Columbia went with the entire 1 to 6 stories being required, regardless of which build. Well, because they did the extension, their 5 and 6 stories for those have to have all non-combustible cladding when you've got 5 and 6 stories. One of the big differences from what British Columbia did is this requirement here. And this has to do with firefighter access to the exterior of the building. And as some of you might know, I did mention that when you have an unsprinklered building, you're permitted larger building areas based on whether you face 1, 2, or 3 streets. Some of you are also aware that facing 2 streets and facing 3 streets has in the code a very strict definition in a percentage of perimeter of your building, related to the percentage of perimeter of your building. And how far it is from a street or access route. For considered facing 2 streets, 50% of your perimeter of your building has to be within 15 meters of a street or access route, and for 3 streets, it's 75%. There is no strict percentage requirement within the code currently when considering facing 1 street. And as a result, the interpretation has been that basically your exits have to face that street. And so your exits have to be within that 15 meters of a street or access, or your major exit, for it to be considered facing 1 street. There was concern that that wasn't enough exterior access for these buildings, particularly since the proposal is to go with slightly larger building areas than the current 1 to 4 stories even. And so the proposal's gone forward for a strict definition of facing 1 street of being 25% of the perimeter of the building has to be within 15 meters of a street or access route. So I've heard that this is a concern in some areas, particularly for infill, where you may have a long, narrow lot, where you're not dealing with that, then it's probably less of a concern. And one of the things, another thing sort of related to this that some people were concerned with was you can create separate buildings just by putting in a firewall under the code. And so there was some concern that you could create, if you had a very large property or a full block, a city block, you could create an entire block of this type of construction using firewalls, creating separate buildings, and that some of the buildings wouldn't have sufficient access for fire services from the exterior. And this is just an example that the Code Center put together. I do have a few slides of these because they did such a nice job of their slides that I didn't want to have to recreate them. This is one example where, in this particular scenario, the configuration shown, because there's no access route or street behind this building, and making the assumption that this is a rectangular building, not a trapezoid, that you're just seeing it in perspective, and that the short sides are the same of each section are the same length and the long sides are the same length. The center portion, what's called Building 2 there, would not be considered facing 25% unless that was a square, basically. And so this particular configuration would not work for this site under these provisions. There would have to be some other design scenario in terms of how to divide up the building and maybe even provision of access routes on the site. The other provision that that is put forward in conjunction with this is that the portion of the street or access route that's used to measure that 15 meters of 25% of perimeter cannot be more than 2 meters below the floor of the first story. And that's, again, because to facilitate firefighter access. Now, you have to sort of picture that this fire truck is not to scale, because if the dimensions are correct, then the height of that podium or berm or whatever you want to call it would only be 2 meters, and I'm only 1.5 meters, and I know fire trucks are taller than me, so the truck would be, you know, higher than probably that berm. And that's the idea, is that in some places in particular, access routes are sometimes at the bottom of cliffs and hills and things like that, and the idea of the 25% perimeter facing a street or access route is so that the fire services have access at an accessible height as well as distance. As well as those things, there are a few other additional fire protection features that are proposed as requirements. One is more fire blocking, even in the sprinkled combustible concealed spaces, of course, unless they're filled with non-combustible insulation, as per NFPA 13. Part of the idea was that we have bigger buildings, and we wanted to, at least in this stage, make sure that we were putting as many barriers to fire spread, especially within concealed spaces. Another provision is double duration of emergency of power supply for lighting and fire alarm systems. Now, one of the subtask groups actually also dealt with a number of issues on the list that related to concerns dealing with construction site safety. And at the national level, the Fire Code, the National Fire Code, does have a section, the section 5.6 in part 5 of the code on construction site safety. And so that subtask group reviewed that section and provided some additional proposals for these 50 and 57 buildings. Now, some of these provisions, it's been discussed at both, well, at the subtask group, at the joint task group, and in some of the standing committees, that some of these seem pretty reasonable for other buildings, as other construction sites as well. But because these proposals are all for a new permitted building height and area, there was no cost-benefit analysis required for the code change proposals. However, if you were to put forward similar code change proposals applicable to existing buildings, existing provisions of the code for buildings that are permitted already, those would require a cost-benefit analysis, and that was not something that was within the timeline that the subtask group and joint task group and standing committees had. So it's possible that some of the more generic, or the ones that seem like they might be a good idea for other sites as well, will be reviewed in the next code cycle to see if any of them should be added in a general way to a majority of construction sites. And some of the debate was, in some cases, that might be all building sites. Some cases, it might be only Part 3-4 building sites as opposed to Part 9 building sites. And so, and that's where part of the cost-benefit analysis would come in. So one example of that would be the unobstructed clearance around hydrants. I mean, I personally believe, and I think the fire service guys in the subtask group in particular thought that this would be a good idea for all sites. If there are hydrants available, then they should be unobstructed, but there's currently no provision in the fire code for that. This is something that currently is going forward just for these buildings, as well as fencing, boarding, and barricades. Currently in the building code in Chapter 8, there is a requirement for fencing around a construction site, but that's tied to safety of the public. That's when your construction site, there's a public way that is nearby that the public might be at risk. And so in the building code, the fencing requirements are tied to keeping the public safe. It was agreed that we probably in these cases, and possibly in others, but in these cases for now, want to keep the site safe from the public, in that one of the main contributors to fire initiation on a construction site is arson. And arson is a crime of opportunity. Yes, thank you. It's a crime of opportunity, and so if you remove as much opportunity as possible, you reduce that possibility as much as possible. And so in this case, we're protecting the site from the public, but the fencing, boarding, and barricade requirements in terms of the types of fencing and stuff that can be used are very similar, almost identical to what's in the other requirements in the building code, so that the same type of fencing can be used to meet both requirements. As well, the same idea behind the access control when the site is unattended. Of course, when there's less people on the site, that again provides more opportunity to do things when it's unattended. So that provision is provided as well. One of the other things that was discussed was requiring that water supply be available when the first combustible materials arrive on site. These sites in particular may have large amounts of combustible materials, although not in every case, but the idea was that you wanted to have the water supply that was available, that should be available for the building eventually, to be accessible for the fire services in the case of an emergency. Some of these I put in the same category as being a good idea for a lot of different sites, but they are being proposed just for the 50-57 buildings at this time. Minimum clearance between exits and waste containers, so that in case you end up with a dumpster fire, any people within the building under construction can evacuate safely. Those jurisdictions that actually allow smoking at all on a construction site, there are no current provisions in the fire code about how to deal with that, and so there's proposals put forward to deal with where they should be located and what type of containers to use and that sort of thing. In addition, some additional requirements for minimum clearances between roofing tunnels and exits and means of egress and exposed combustible materials, again to keep those people on the construction site safe from accidental fires in those cases. We were fortunate in some aspects that British Columbia decided to go first because they right away had to start thinking about earthquake design. And so over the last 4 years, there's been a lot of work done. The code didn't have the factors necessary to deal with taller wood buildings because taller wood buildings weren't permitted under the code, so there was no need up until 2009. As a result, the very first pass that BC did, was very conservative. The 2012, there's been some updates provided based on people reviewing information from other jurisdictions like Japan and Europe and that sort of thing, as well as new information being developed in Canada. And my understanding is that the 2015 code change proposals also, now I believe that under the actual website, consultation website, these earthquake design proposals aren't under the mid-rise package. They're under Part 4 structural things, in part because some of them actually, there were some questions raised about other types of construction as well. So there's some other ones that are tied to the whole review that was done of the safety factors for lateral earthquake force and that sort of thing. So those are there as well. The building envelope people at first thought there might need to be some changes, but then under review of their Part 5 in particular, it's quite performance-based, and so they've only proposed some additional appendix information to just basically remind people that the building envelopes that are being used for 1 to 4-story buildings of this type may not be necessarily applicable, so review needs to be done to ensure that with the higher wind loadings and other things that those building envelopes will work effectively. And of course, British Columbia has already, looked at some of these aspects. So I'm going to actually pause here for now to see if there's any questions, and CSP is going to look to see. I know we've got something flashing here. I'm not sure exactly if any of them are. I think the only thing that seems that is relevant to the actual technical content is I believe that CHBA they can provide a copy of the webinar.
Posted on our website?
Yeah.
Yeah, the webinar will be posted on the CHBA website, along with the webinar that we did last week on proposed changes to the Part 9 section of the building code. So there'll be 2 webinars that will be posted on our site. If anyone has any questions for Inika at this time, please use the chat feature to ask them. Otherwise, I think we'll move on and we'll collect those questions and review those at the end.
All right. So what I'm going to do next is some of the mid-rise research that has been done, in particular a large single joint project that has been done at the National Research Council in partnership with the Canadian Wood Council, FP Innovations, which is the wood industry's research organization, as well as the provinces of British Columbia, Ontario, and Quebec have been partners in this research. And the research itself covered 3 broad categories. One was building envelope, another was acoustics, and the third, of course, was fire. Structural and earthquake issues are being looked at outside this project. As I said, some of it's already been fed into the code. There's other research facilities and bodies that are doing that. FP Innovations is involved in some of that, as is the Canadian Wood Council, but it's not part of this particular project that we've been doing in relation to mid-rise. When it comes to building envelope, I'm far from being an expert in building envelope, but I'm told that what they had to do was identify all the envelope details they wanted to examine and choose climate locations and loadings based on those locations. And the guys that were the researchers that were looking at this actually had to wait a little bit to see if any of the decisions in terms of what we wanted to test on the fire side and the acoustic side might affect the envelope details that they wanted to investigate. So they actually started their part of the research quite a bit later than the other 2 groups. But they have done water penetration lab experiments and hydrothermal modeling and analysis. And the main point of their part of the research project is to look at some alternate wood-based building envelope solutions that have been developed in British Columbia and elsewhere in conjunction with some of the, practical expected requirements just because of structural and that sort of thing, and whether or not those envelope solutions meet the National Building Code 2010 Part 5 requirements, but also whether they how they meet the National Energy Code for Buildings 2011, their overall heat transmission requirements for the maximum envelope overall heat transmission requirements. In acoustic, as I mentioned, some of the structural things that we were looking at, because when you have 5- and 6-story light frame wood buildings, you end up particularly on the 1st and 2nd story, with much higher structural loads that you have to deal with. And as a result, we've been seeing some variations on structural walls on those levels for which we didn't have any specific information, any tested information. In terms of acoustics, the experts could tell us whether probably the sound transmission class rating would go up or down, but not by how much, and what effects would cancel each other out. And so there was a large group of sound transmission class rating tests that were done on late frame wall assemblies. One of the aspects was staggered studs, which hadn't been looked at in much detail before, as well as walls with wood shear panels in them. And with the single studs, we're seeing sometimes really close spacing to deal with the structural loads, up to the point where in one case I saw 100 millimeters on center, which means you've got about 40 millimeters to get your hammer in to try and put the toenails in to nail this to your top and bottom plate. So people were realizing that that was starting to get a little crazy, so they started doing what I sort of call triple stud and double stud walls, and sometimes they're just single rows, but sometimes they're staggered rows like this example. And how would that affect your acoustics? You're not necessarily fastening your gypsum board or your other membranes to each of those three, but there is more there if you don't have resilient channels, and even if you do, how does that affect the sound transmission class rating and all that? So I have to admit I've been a little envious of the acoustics guys over the years, because there's a non-destructive test. For the same price as I do one fire resistance test, they can get, 10 or 15 assemblies tested, because they just swap out, a single layer of gypsum, or take off the old gypsum and put a thicker layer on, or, the base assembly can be used for multiple things. So they've got a large matrix of testing they've done from which they can base models and extrapolate. As well, we've seen this new product, cross-laminated timber, that sort of started going gangbusters in North America over the last 3 years. And a lot of the information we had on sound transmission class ratings was not generic. It was proprietary information based on European systems. And so there was a desire to actually have some generic information. And so they've done similar testing on cross-laminated timber systems, walls and floors, again looking at how the attachment of gypsum affects, first the bare panels, then attachment of membranes, attachment of gypsum using resilient channels, if screws or nails make a difference, spacing, all sorts of different aspects again. Now, a sound transmission class rating is a laboratory test of a single wall or single floor, and as those of you who have built structures know, sometimes how you put those walls and floors together can really affect how well you maintain that effectiveness of the sound transmission class rating. And that is due to what's called sound flanking. And more that has been discussed as an issue, and the wood industry had done a lot of research into light frame wood assemblies, the sound flanking in them. But again, because we have these wall systems in particular that have changed quite a bit, especially on the first and second story to deal with structural loads, it was decided we'd also see how that would affect the sound flanking, because of course you've got more members coming into your bottom plates. That's going to, possibly have more sound transmitted through your floor assembly, that sort of thing. So they've done that testing. And they did also sound flanking testing for cross-laminated timber. Now, cross-laminated timber is a massive timber system, and so the NRC acoustic scientists thought, well, we know that there is a calculation methodology for determining the flanking of sound for concrete systems. They're a massive construction system as well, and they wondered if CLT would behave in a similar manner, that a similar model with maybe different factors due to the different densities and mass and therefore different, sound transmission functions. I'm not sure, it has to do with hertz and all that sort of thing. Whether they could modify the model to work for CLT. And the testing that they've done has been promising. And unbeknownst to us, we discovered just, I think in June, a research group in Spain has been looking at a similar methodology, and so we've sort of got independent confirmation that this method might work. Now, one of the reasons why acoustic flanking sound has become even more important is that I don't know if you guys went over this in your previous webinar, but there is a code change proposal going forward looking at requiring a parent sound transmission class, which incorporates the idea of dealing with sound flanking. So a lot of the information I just talked about will be added to documents let us put together by a consortium group at NRC bringing together all the information possible on STC and ASTC, or flanking, for junctions and that sort of thing. It's available, and there's the information. It's not easily findable. You have to search for it. You can't. There's not a single page. The URL for this is horrendously long with a bunch of letters and characters like they like to do. And so that's why I've sort of given you the directions. If you go to the main page, you choose English, you choose Publications tab, go to the archive, the Publications archive, and search for that report number, you'll find that information. But as that group realized, the number of possible combinations of how to combine walls and floor assemblies is almost infinite. And so although this guide has basic information on what to look for and some examples, not everything can be put in there. And so my understanding is that there's another group that's at NRC, consortium group of industry and NRC, putting together software called SoundPath that will also assist. My understanding is also that, unlike the wood industry, who does have a lot of this information, the light frame steel industry does not, and is having to generate some of this information, at least on the flanking side. So then, on top of the sound transmission class and flanking information, we were looking at fire information. One of the first things we did was also look at standard fire resistance testing. And again, because some of the wall assemblies in particular structurally are being constructed, have a different configuration than what we typically have used. And we were pretty sure we understood how they would perform, but by how much again, and what would affect fire resistance one way or another, and by how much. We wanted to actually quantify that. So we did 5 full-scale standard fire resistance tests of light frame wall assemblies. And again, we looked at staggered studs, which we didn't have a lot of information on, wood shear panels, which we also didn't have a lot of information on that we could use, and again, looking at things like the triple stud. And so we will have additional information that we can provide on the specifics of those aspects. One of the other aspects we looked at was standard exterior wall testing. I mentioned in the code change proposal that CAN-UL CS134 is one of the ways to test exterior cladding to be allowed. The proposal is for the 5th and 6th story on these buildings. It's also used for spatial separation requirements for sometimes when non-combustible cladding is required due to spatial separation requirements. You can meet, if you've got a cladding that meets S134 in conjunction with the wall assembly system being used, it can be used. And this is also used in the requirements for permission in buildings required to be of non-combustible construction to permit any type of combustible elements in non-load-bearing combustible elements in that exterior wall assembly currently in the 2010 code. And so one of the things that we decided to do was that in the past there hasn't been a lot of call for cladding systems on a wood-based structural system, in part because the S134 requirements in for non-combustible buildings required that all the combustible elements, be non-structural, and so there hadn't been a lot of testing done with structural wood elements. So it was decided to try and come up with a series of tests that would test a base system so that any non-combustible cladding could go onto such a system and would be good to go. Because not even all non-combustible claddings would pass this test when there are other combustible elements in the wall assembly. And because S134 is a test of the entire wall assembly, it was decided to go this direction. So what was done was 4 tests. 2 of them were on light frame 2x6 wall assemblies with spray polyurethane foam insulation. 1 used gypsum sheathing, standard exterior gypsum sheathing, and the other used fire retardant treated wood. 2 assemblies were simulated CLT with 2x6 furring using XPS foam insulation. And again, 1 of them used gypsum sheathing and 1 used fire retardant treated wood sheathing. The idea being that any of these systems, these 4 systems that were tested, that pass the requirements that are within the building code in section 3155 for non-combustible construction, would then could be used as a base system for any type of non-combustible cladding. Combustible cladding systems would have to be tested in addition to this. But it would also provide base information, data, for manufacturers of such systems to have to know where they might be, because this is a large test. I didn't actually talk about the assembly, but it's almost 7 meters in height. It's a 3-story wall, basically, with a single opening. And I'm trying to remember, something like 4 meters across, maybe. So, and the only facility in the world that can do this test is NRC's lab out near Mississippi Mills. And so, they sort of get spurts of people wanting to test for this, but they're the only facility that has this thing. So it's quite an expensive test to do. So you don't want to have to test every possible combination if you can get away with some generic information. The last thing we did in terms of fire was looking at something, a concept called encapsulation. It's a concept that the Europeans have been using as one means of dealing with combustible structural elements versus non-combustible structural elements. The idea is that the main difference between combustible structural building elements and non-combustible is that combustible structural building elements may eventually contribute to the fire itself. They can provide fuel load once they become involved. And so if you can encapsulate them for a certain period of time so that they do not become involved in that fire, then the idea is that for that period of time, they are performing similarly in that aspect to non-combustible construction. Of course, the actual fire resistance aspect has to be dealt with all the construction types, and so that would still have to be in place. But in dealing with encapsulation, we first wanted to get some very basic research information, data as to how some of the typical materials that we might use for this type of encapsulation actually perform using the standard fire resistance temperature time curve. And we use the intermediate scale furnace to try and hopefully, if this is something that goes forward as a concept, we could develop a relatively easy and smaller scale than full scale test to evaluate new materials. And so using this horizontal furnace they have at NRC, a smaller furnace, we measured things like the heat transmission through various types of materials that might be considered for encapsulation. Different thicknesses and number of layers of gypsum board, cement board was tested, and gypsum concrete was tested. And of course, what this would do would mean that if other materials came along, such as magnesium oxide board that is being proposed in some areas, those materials could easily test to determine what their efficacy would be as an encapsulation material. In conjunction with that, we did some very large-scale testing where we did a 2-story apartment building section. So we took basically a single bedroom apartment unit and did 2 stories, so 2 units stacked on a 1-story concrete base, and fully furnished the middle story as an apartment, and basically did a fire test. We did 3 of these tests with 3 different types of construction. One was light wood frame, one was cross-laminated timber, and those 2 we used the encapsulation ideas so that all the structural members were encapsulated in 2 layers of Type X gypsum board. And then we did a 3rd test, which was the exact same scenario and footprint using code-conforming light frame steel assembly that would be code-conforming for a similar type of building. 6-story, 5 or 6-story, non-combustible construction, 1-hour fire resistance rating. And so these are just a close-up of a couple of them. The first one was the light wood frame. This is the CLT. You really can't tell the difference other than for the you can see the rim board changes because it's actually the CLT in this photo, although it's not that clear. But this is the actual layout of the actual apartment. And so it was a one-bedroom apartment, fully furnished, and the fire was initiated in the bedroom. The unit, the main floor unit, the unit above was fully instrumented. We had thermocouples to measure temperature, not only throughout the space, but in between gypsum board layers, within the stud cavities, the floor ceiling cavities, in between layers. There was a full floor system in here in that it wasn't just subfloor. It was, in the light frame system, wood system, it was I-joist with a structural wood panel subfloor, plus we used cement panels to simulate a concrete topping so that we didn't have to wait for the concrete to dry. And then we put a full flooring system on there, a wood floor system with acoustic material underlay and all that sort of thing. And we basically ignited the bed and watched the fire progress and recorded all this information. In addition to that, we also had the towers you see on the outside of the building to the left. Those are heat flux gauges, and so you can see that they're aimed at the windows to determine how much heat is being generated, and the measurements are at that distance from the building, and so those are different distances from the building. And you might vaguely be able to see in the shadows above the building is what's called a hood, and it actually captures all the heat and gases generated from the fire, and there's instrumentation in there that can then calculate what the heat release is of the fire, therefore how much fuel is being consumed at any given time. And the main idea between the two wood systems and the steel system was to look at the contribution of the structural wood systems to the fire with respect to fire growth and heat release rate, and compare the steel frame system, which the only combustible materials were the contents of the rooms, and in the other two where you did have combustible structural elements. So that's the research we've done. As I said, the reports will be forthcoming in the new year. NRC has a deadline of March 31st for all this project to be completed. So there are, as you can imagine, there are multiple test data reports, and then there's the analysis that has to be completed of all the information. I know I've reviewed 9 reports so far. I've got 4 more to go, and I believe there's at least 4 more to be written, finished in a draft form to be written. So a lot of data has been generated. There should be a good amount of analysis as well. And so look forward to that in the new year. Oops. One of the other things I wanted to mention, in part because I was on the task group that did this, and I really think it was a big achievement for the code process, this code cycle. A lot of you may be familiar with the Appendix A Part 9 generic fire resistance rating tables. And some of you may also be aware that Part 3 does not reference those tables. And so I always get the question of why can't I use those tables for Part 3 buildings? And there's really not a great explanation other than the fact that the data that was used to update those tables was never incorporated for Part 3 buildings, in that currently the only methodology in the code for Part 3 buildings was the component additive method. And I think in the past, everybody looked at this and thought, oh my God, this is a huge monumental task. It's not as simple as just filling in a table. It's going to take a lot of work. And so finally, this code cycle, we got through to started at least, and there's been a number of changes proposed. It's in this consultation as well. As I said, the previous versions did not include a lot of the things that we currently use in our construction. And so in a lot of ways, there were, at least for wood assemblies, there was only no more than, I don't know, 8 or 9 assemblies total that you could develop out of that methodology. So it wasn't that useful other than for the membrane-only fire resistance rating table that's later in the methodology. The proposal that's gone forward now adds new provisions for double layers of gypsum board. It's added load-bearing cold-form steel studs and joists. I have to give them a shout-out since we worked on that as well. But also wood eye joists have been introduced and more wood truss types. As well, there's much more information on different insulation types, as much as we could at this point, as well as the locations and how they affect the fire resistance ratings calculated within the methodology, as well as how additional floor toppings affect the fire resistance ratings. In addition to that, the current methodology was completely silent on the use of resilient metal channels, which of course for residential buildings and the acoustics requirements is pretty much necessary. And so that information has also been added in large part. So the methodology as proposed has really become a lot more, I think, a lot more usable. The number of possible combinations has grown exponentially. I haven't done the math on that part yet. That's something I have yet to do, but certainly it's a lot more than 8. I would think that with the various combinations there might be hundreds, especially if you look at the options of different spacing of joists or studs and that sort of thing. So there is more work to be done, and of course the fire resistance tests that I mentioned that we did on walls, that hasn't been incorporated, so future work will probably relate to wood shear panel stuff and double and staggered stud walls, as well as what happens with multiple studs together, things like that. But it certainly, I think, the task group deserves a bit of a hand for having done so much work. As well, in this code cycle, some of you may be familiar with, in Appendix D of the Building Code, in D211, there is a methodology for calculating fire resistance ratings for glulam of 1 hour or more. And that methodology, too, has not been updated in a long time. And in the United States, a similar methodology is permitted to be used for both solid sawn heavy timber and glulam. And so I often get the question, why can't heavy timber be used? Why can't it be used for heavy timber? And I said, well, because we haven't changed the code to say you can. Although we have confirmed that the methodology is good for that, we didn't get the wording changed. CSA 86 felt that perhaps what we should do is provide methodology for fire resistance for a lot of different large cross-section wood elements. So glulam, solid sawn heavy timber, and structural composite lumber as an informational annex in CSA 86 in this last cycle. The methodology is similar to what's in. The basic principles are similar as to what's in Appendix D, but one of the other things that has been determined over the years is that some of the methodology in Appendix D is a bit overly conservative for some types of beams and columns. Because of the nature of the methodology, it's nice and simple, but that simplification often means that you're more conservative in some cases than you need to be. As a result, a proposed revised methodology that also fits more closely with the current limit stage design methodology of wood design for structural. It relies on the same factors and that sort of thing, as opposed to the Appendix D211, which was developed under working stress design, still works for limit stage design, but doesn't have any sort of official tie to it. So those two aspects have been revised within this methodology. As I said, it's an informational annex. It's not mandatory. The public comment on it at CSA closed November 4th, and my understanding is there wasn't a lot of significant adverse comment, and so it's likely that that annex will go forward in the 2014 edition. It currently doesn't include a methodology for cross-laminated timber, but the expectation is that the next phase of CSA 86, the next cycle, will include that, in part because the task group that worked on the fire resistance wasn't sure that on the structural side CLT would manage to make it into the wood design, into the standards, so we didn't want to have fire information if you didn't have structural information to begin with. There's a bunch of other additional activities that have been going on just for your own information if you want to look them up when they become available around the world, basically looking at wood construction in part related to fire, in other parts related to structural. The Fire Protection Research Foundation in the United States, which is the foundation of NFPA, which does the standards like NFPA 13 for sprinklers, they commissioned a report called Fire Safety Challenges of Tall Wood Buildings. I haven't heard that it's been published. I thought it was supposed to be the end of November. It's probably going to be published sometime in December then. So look for that on the NFPA. I think FPRF, their link is on the NFPA website, so you could look to see when that comes available. That report is being done by ARUP, an international fire protection engineering firm, and it was commissioned for the insurance industry who often do research through the Fire Protection Research Foundation. As well, the Canadian Wood Council will be publishing early in the new year a fact-finding report that we commissioned from a consultant on historic heights and areas, and it should be a very interesting report. The report itself is quite extensive and contains extracts on heights and areas from English language, mostly, I believe they're all English language codes from quite early on to current day, and focusing in the last 60 years both on the U.S. and on Canada, prior to that internationally. The hope is the consultant has also generated a large database of documentation that a lot of this information came from electronically, some of it never before available electronically, some of it very difficult to find, and so we're trying to figure out a way, of course there's copyright issues and that sort of thing with some of the newer information. But the Canadian Wood Council is trying to figure out a way of creating making that database accessible to everyone. As well, FP Innovations has created a tall wood building guide. The final version is due March 2014. My understanding is that there is a 90% done version that's available currently. If you look at FP Innovations website, I believe the information's there, how to get it. FP Innovations had produced the CLT handbook. The fire chapter is currently undergoing revision to include new information. And on top of that, academia, through the National Science and Engineering Research Council Commission, has a program called New Builds, and there has been some work in wood and fire in particular, although some other areas as well in wood construction. But the projects I'm familiar with are under the fire behavior section, and there have been 2 master's theses done here in Ottawa that I haven't managed to, that were just published in the spring that I haven't managed to read yet. That type of information is the type of thing that FP Innovations and CWC will be needing to go through to put together information that's in a form usable for designers and builders, because I mean, the majority of people don't want to read a 200-page master's thesis to get a design detail. So hopefully that information. There's other ones that have been done in the recent past to do with heavy timber connections and fire and that sort of thing, and all that information, too, needs to be synthesized. And as I said, the Canadian Wood Council is one of these bodies that is part of our mandate is to create technical information and tools for builders, designers, regulators. So, look, check our website. We seem to be doing a lot of stuff, new stuff lately. And in particular, I just want to mention, sort of unrelated to my area of expertise, but one of my colleagues, Rob Jonkman, was involved in this, and we produced a wall thermal design calculator. And its purpose is to provide designers with climate zone appropriate insulated wall assembly solutions. And the idea being that it'd be nice in one place to be able to do the different, to compare or to have the information for different energy efficiency requirements across the country, because different locales are using different requirements. My understanding is that it does the total nominal insulation value that is required in Ontario, It does the total assembly insulation value through cavities that is required in Quebec, and it also does the effective insulation value that is in the National Energy Code for buildings, the Part 9 National Building Code requirements, and similar requirements in Vancouver. And so hopefully this is this is being updated all the time, and so I've been told it should be quite useful. The other aspect is that it provides climate-specific durability assessments of wall assemblies, so that you may have 2 or 3 different types that provide the same R value, let's say, but depending on your locale, one or another might be better for your climate based on durability, and so it also provides that assessment to you. So hopefully, if you're interested, you can go to the CWC website, and there's the direct link to the page with the design calculator on it. So that's my presentation today. I think I've got a couple of questions here.
Yeah, it looks like we've got one question here, Inika. There's another question came in, but let's do the first one. How did the BC Building Code and Fire Code respond to the fire in the first 6-story building in 2011?
Well, the fire in the first 6-story building was under the construction phase, and so certainly at the national level, that was the aspect that the subtask group on the Fire Code looked at, and that was one of the reasons for the proposed changes for the Fire Code. With respect to the BC Building Code, they too have construction site safety requirements in their Fire Code. I know that at the provincial level, they have been putting out additional guidance in terms of through the I think through the Fire Marshal's office in terms of just construction site safety requirements and that sort of thing. And I think one of the aspects has been education with builders out in British Columbia, because they're already building these buildings, as well as keeping the fire service in the loop, because often they're the ones that are responsible for inspecting construction sites for fire safety during the construction period, at least in British Columbia. In other jurisdictions, there, say like in Ontario, it's a different provincial department that's responsible. It's the Occupational Health and Safety group that is responsible, and so these things are all a matter of education and enforcement.
Okay, we have a second question. Have shear wall assemblies with a considerable amount of built-up studs, say 8 or more studs, packed at each end of the wall, being tested for fire resistance and sound transmission?
Well, certainly for sound transmission, multiple end studs was something they looked at, and so they've developed information on that. My understanding is, and I have to admit it's been a little while since I've looked at the acoustics information, but my understanding is it's sort of there's a point at which it maxes out, and so I think I don't know if they've actually done 8 or more, but they developed information that sort of says, it's not going to affect it anymore once you get to a certain number. With respect to fire resistance, because of the nature of the fire resistance testing, multiple end studs actually would be expected to perform better than otherwise, in part because one of the major way that wood walls fail is through buckling of the studs once the fireside gypsum falls off. And so when you have built-up studs, then your buckling capacity is much greater than if you have single studs spaced even at a small distance apart. And so with respect to that, what we did do with the fire resistance testing was demonstrate that just because you have more studs in terms of material in the wall, some people believe that fire resistance has to do with the fuel load in the wall, that does not affect the fire resistance, and so that aspect isn't affected by multiple end studs.
Okay, a third question here. Must the wall assemblies be entirely complete, i.e. studs, insulation, gypsum board, as you rise through the floors?
yeah, I don't know if they mean during construction or if they mean finally, and I'm not sure what they mean by as you rise through the floors.
Guessing it would be through during construction.
During construction? Yeah. Currently, there is no proposal within the code changes to require that each floor be completely finished before the next floor is constructed. I mean, there was some discussion at one point dealing with stairwells, staircases, talking about that, but the nature of the construction materials, in particular the gypsum board, does not do well with a building that isn't completely finished with a roof on it. So it was decided that constructability, there was too much of an issue. So there currently is no provisions for that. Of course, in terms of other aspects, I mean, there are guidelines that BC has developed, you know, certainly some aspects like if you are creating multiple buildings using firewalls, and depends on the type of firewall, installation of those, and if you've got them installed, the timing of installation of fire doors and that sort of thing can be of assistance. But if your entire envelope isn't in place, then you're going to get fire spread otherwise as well. So, you know, there's nothing in the requirements that require these things.
Another question here. Is there a timeline for allowing 5 to 6 story buildings in Alberta?
Well, I know that there's a couple of national code people on the line, but my understanding for the national process is that the public consultation will close December 23rd. All the public consultation comments are gathered by NRC Code Center staff and parceled out. My understanding is that in the cases where there were task groups or joint task groups working on those topics, those task groups or joint task groups will be called together to review the code change comments and provide recommendations to the various standing committees. If they were ones that were generated without a task group, then they'll go straight to the standing committees when they meet in the spring. So between January and the spring when the standing committees meet, the joint task group on combustible construction, let's say, will be meeting to review the code change proposals. The standing committees will then review the recommendations and make their final recommendations to the CCBFC. I guess what you'd call the best case scenario is that only minor editorial changes are required to any of the code change proposals, let's say for mid-rise. So then that recommendation of basically a final package goes to the CCBFC. I'm not sure when the CCBFC will be meeting to approve that package.
Could be balloted.
Or it could be balloted, and so the potential is there for somewhere over the summer for that to happen or into the fall, so that by the end of 2014, the mid-rise code change proposal package would be completed and ready for publication. Of course, because of the nature of having to deal with print format and web format and other electronic formats, the whole publication process takes some time. So the expectation is that the published version will not be of the 2015 code will not be available, of course, until sometime in 2015. However, my understanding is that the package of any finalized changes goes to the provinces once they're finalized by the CCBFC process. And so it's up to each provincial jurisdiction as to what they want to do with those. My understanding is British Columbia is looking at their process as to how they're going to, once it's in place, once they've been finalized, whether they'll adopt them early, what that process will be, without waiting for the national to publish them physically. So that is an option for Alberta. I have not heard anything from the province of Alberta as to how they plan on handling this. And so the question will be whether or not they will be looking at a pre-implementation period or not, or whether they will wait for the entire code to be published in 2015 sometime and then go through their own code process as per usual with all the code change proposals. So that'll be a provincial discussion. Yeah.
Well, we only have a few minutes left here to stay on our 90-minute timetable, and I see we've got one more question here. Was there any discussion at the national level around requirements for non-combustible exit stairs and elevator shafts.
At the national level, it was one of the, I believe one of the 65 issues that was raised was, you know, the construction of exit stairs in particular, not necessarily elevator shafts, but construction stairs. And at the national level, the co-chief's proposals went forward without any requirements in that aspect. The discussion surrounded the fact that we are looking at construction or building areas. There's still only, you know, at least 1/4 the size of non-combustible construction. That there are buildings that are permitted to be 4 times or more in size in non-combustible construction with 1-hour non-combustible stairs, shafts for exits, and that the main provision, the main rationale for fire resistance of stairwells is related to occupant evacuation, and because you have smaller floor areas permitted under these than in non-combustible buildings, it was expected that 1 hour would be sufficient, and that performance-wise there was no expectation of a necessity of changing the construction type. And so that was the discussion that occurred. And at the national level, the fire services felt that the 25% perimeter requirement provided them enough external access, and that was the methodology that was typically used for these lower type buildings, as opposed to high-rise buildings where they do need to perhaps stage in stairwells and that sort of thing to be able to fight a floor fire that's much higher up. So those were the discussions were had, and the decisions made were to not have any requirements related to non-combustibility of exit stairwells and elevator shafts in these types of buildings.
Okay. Well, as we reach the 90-minute mark of our webinar, I'm going to draw it to a close here now, and I'd like to take this opportunity to thank Inika very much for coming here and imparting her information to us, and hopefully we're all the wiser for that. I'd also like to thank all of the people who attended this webinar. I know your time's important. Hopefully you feel you got value for the time you spent with us today. We intend to do more webinars as the need arises on different subjects. So if you have comments or you have constructive criticism or topics, please feel free to email those to us. You can send them to sharp, S-H-A-R-P, at chba.ca. And I would like to now call the webinar officially closed. Thank you, everyone, and goodbye.